Very good morning, students. In today's class, we are going to start with Module 5 Digital Signal Processor and Architecture. So, let me give you intro about this particular module. So, here you are going to learn about the DSP architecture and what is the architecture we are going to follow in the case of digital signal processors. So, if you observe the design of the general microprocessors and microcontrollers, it is based on von Neumann architecture. And whereas the same architecture we can't use it for the digital signal processor, as it is having some special features such as it requires operations of fast Fourier transform, filtering, convolution, correlation and real-time sample-based and log-based processing. Hence, it needs a different dedicated hardware architecture which is named as Hubbard architecture. So, all the digital signal processor will be using this Hubbard architecture in general. So, let us see what is von Neumann architecture. So, the general microprocessors and microcontrollers, it is based on this particular von Neumann architecture. So, this particular architecture, it consists of basically the input and output devices, address generators, program control unit, arithmetic unit and a single memory for both the program and the data memory, and there is a single bus which is used to access the address as well as the data bus. And you can observe here there is a single memory which can be used for both the program and the data. Hence, the speed of the processor is less when compared to the Hubbard architecture. And also we are making use of a single bus in order to access the data as well as the address. So because of all these things, we found that the speed of the von Neumann architecture is less when compared to the Hubbard architecture. So in order to overcome this disadvantage, we are going for the Hubbard architecture. So these are the things what we have discussed just now. It consists of the program memory, arithmetic unit, program control unit, and as I told, the processor, it is going to fetch each and every instructions in a serial way and it is going to execute in a serial manner only. Why? Because based on this only, the speed of the processor is very less. So once the CPU fetches the instruction from the memory, it will decode it and it will start executing that particular instruction. And the instruction basically, if you see, it consists of two parts. One is the opcode and another one is the operand. So the opcode which will specify what is the operation the CPU is going to perform and it is going to perform on what data it will be available in the operand. So once the instruction is executed, you can find that there is some you can find the storage of data in the input and output. There will be some changes in the output data. And this particular von Neumann architecture is having issues with respect to the speed, which is due to the single and shared memory for both the program and data instructions. So if I want to increase the speed of the von Neumann processor, what we can do is we can increase the number of buses as well as we can increase the size of the memory. And if you do so also, it's not that it is going to increase the speed in a significant way. So all these disadvantages will be overcome in the case of Hubbard architecture. So this particular block diagram, it is the Hubbard architecture. So the Hubbard architecture is used in all digital signal processors because of the special features what we are going to use in digital signal processing. So the Hubbard architecture consists of the input output devices, address generators, program control unit and arithmetic and logic unit, and additionally you can observe here there is a separate memory for the program memory and the data memory. And you can observe the program memory and the data memory which is as a separate unit in the case of Hubbard architecture. And also you have this MAC which is a dedicated hardware in order to do the multiplication. Okay, and you have the shift unit which is used for the scaling operation in the case of digital filter techniques. And additionally, you can observe we have two program memory, one at the top and another at the down. You are having two program memory address buses in order to increase the speed of this Howard architecture. And additionally, you have two data memory address buses in order to access the data memory available in the processor. And the advantage is we are having more memory spaces, and also in order to access this program and the data memory, we have separately the address lines for the program memory and the data memory. So this is what I have explained now. And let us compare the execution of two architectures, that is the von Neumann architecture and the Howard architecture. And if you observe the execution cycle of the von Neumann architecture, first it will execute. So this is the first cycle where we are going to have the fetch. So during the fetch operation, the processor will obtain the opcode from the memory, and it will and the control unit will decode that particular instruction, and it will determine what is the operation the processor is going to perform. And during this fetch cycle, once it determines the operation to be done, it will be done in the execution cycle. And once this execution is completed, the content of the register and the memory will be modified based on the results. And once this process is completed, then the processor is going to fetch the next instruction, and it will continue as such. And if you observe the complete timing cycle, it will be executed in a serial manner. That is, first the fetch, later execute, again it will fetch the next instruction, it will execute. So in the serial fashion, we are going to execute each and every instruction in the case of von Neumann architecture. So let us compare this execution cycle of von Neumann architecture with that of Howard architecture. So this particular diagram explains you about the execution cycle of the Howard architecture. And if you observe the execution cycle, it seems to be like the execute and the fetch are overlapped. That is, during the execution of the first cycle, the fetch of the second instruction will be happening. So this will call it as overlapping. And also in terms of DSP architecture, it is called as pipelining operation. That is, parallelly we are going to do the fetch as well as the execute operations here. And because of this, I can say that the speed of the processor is dramatically increased when compared to the von Neumann architecture and its processor. Okay, and this Howard architecture we are going to prefer for all the digital signal processors. As I told, it is going to fulfill all the requirements of the digital signal processing algorithms, and also it concentrates on the heavy data flow through the CPU. So this particular architecture is having all the features what the digital signal algorithm we are going to execute. Okay, thanks for watching. Let us continue in the next video. Thank you.